Okay, hello everyone. This is Peter. So today we are talking about the topic about the kinematic. So the kinematics actually is part. If you want to describe the trajectory of the motions, you got to have know some few words to help you to understand how to describe in physically. So the first that the words is the particles. So actually, we often use the particles to stand for something an object. So for example, that if you see here, this is a rectangular. However, in the physics, we only consider it just a point. So we use a point to represent this as particles. So and the particles over here have some properties So the first that is the property is that these points will have the max. So he present the max, and also this particle doesn't have the volume. So if the particle doesn't have the volume, which means that you just have to ignore all the shape of this particle into you can just think it as just like a point like this one. Okay, so this is the particle. So this is really powerful or well to help up to construct a physical system. Okay, so the first that this is a Okay, so when we try to want to describe the motion of the trajectory, so the first step we got to have some coordinates. So the coordinates is the very important. So in our high school physics, we often use the coordinate is the rectangular coordinates, so like these ones. And in the transversal axis is we also call the x, and the vertical axis is y, and the intercept of the x and y is means that is here is the origin. So actually, there is some interval between there are some intervals, 1, 2, 3, 4. So you just label it 1, 2, 3, 4, and also in a vertical axis is 1, 2. So if you want to describe the 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 place of the object on in these coordinates, for something for examples, if you want to describe this point, so I will call this point is the 1, 1. And also if we want to name this point, we will call it is the 4, 2. Okay, so you get a point. So we will call these kinds of things we will call these points a name that is the position. So if you know the position, the first that you got to have know the origin of the intercept. Okay, so this is and this origin also will call him that we will call the reference point. So we will call him the reference point. So if you want to know the reference points, that's really great. Okay, so when we finish out to name, when we finish out know the coordinate positions, and if you want to describe the distance, or maybe you want to know how long it passed or how long it traveled, so there are two ways to help us to describe these things. So the first one will be we will use the uh, path length. So the path length, which means is that for take something for examples, if you start from this point, we call it 8, and also you go to this point, we call it B's. Okay, so you can have different way to get to the A to B. So I take something for example, maybe this curve like this one, or maybe just going straight, or maybe you can more comfortably pace right like this one. And all these, more complicated like this one. So these stand for the numbers stand for the different paths for the from A to B. So you got to memorize. So you got to know these ones. Okay, so path length is a very important thing. And you can just think that the path length actually is the route that you're passing, you traveling back, you traveled. Okay, so this is the third times. And also that you got to know the one important thing is that if you're talking about the path of length, it means that you're just talking about it is a scalar. This is a scalar quantities, physical quantities. So what's the meaning of the scalar quantity? Which means you don't have to focus. You don't have to care that don't care. You don't care the directions. Okay, so no directions, only the quantity, or we call the magnitude. Okay, so when we finish talking about that pace length, and here is another web to help us to know that is the physical quantity is you call the displacement. Okay, so in also the displacement, which means is that you can classify into the two can I can help you to it's involving two parts. So the first part will be the first part actually is the directions, and another will be the magnitude. So I just take the example for if you point, here is a point 8 and here is a point B. So if you want to from A to B, so you just like this one. Okay, so this is great from A to B. And also you can there's something like from B to A. Okay, so from A to B and from B to A, this is a different displacement. So in physics, so we will stand like this one. So the delta XAB is not stand for delta XBA. If you focus on the directions, so we will use an arrow over arrow on the tables like this one. So here this is not different. Okay, however, the displacement has definitions. So the definition is the final initial final positions and minus the initial position. Okay, so these two things. So this is like this one minus or subtract these ones. So this is different. So the displacement focus on the direction and also the magnitudes. Okay. However, if your path just like this one, is really complicated like this one. However, that this path only the displacement is just like this one, like this. So you can find that if we have different paths, however, if the final positions and the initial positions is the same, you will not change if you will not change the magnitude of this, only change the directions. Okay, so the kinematics actually that we focus on the two ways to help us to describe the describe the distance. So now, if we want to describe the something, another things that you would call the how fast if you want to know the how fast a particle traveling, so maybe so we will there is some more definition. Well, definition here is here. First of one is the speed, and the speeds actually we use the v to represent it, and the definition symbols that is one, and we can go the denominator of the numbers. The denominator of the number is actually the path length. So this is the path length. So okay. So in the variation of the path length and over the variation of the times. So this calls the definition of the speeds. So we can find out that this physical quantity doesn't care no directions, right? Okay, so that's great. And also that we will quote average. So if there is a long time, there's a long time, so we use the a bar to represent it. So if you use the v bar, means that like this one, we will call this average speed. Okay, so however, if there is another thing that we call to talk, because we just meaning there is a point, so the point we will insert a label like this one, the limit symbol. So the limit symbol means that the relation of 10 as is in the limit in the zeros over almost nearly the zeros. So this is the definitions. So we call this is the instantaneous speed. Okay, so this is the speed of the speed of names, and also if we want to describe something with the direction, we will use the word the velocity. So the velocity we will add some the arrow over the symbols which we present the directions, and here is the variation of the displacement over the duration of times. So this is and when we're talking about so this is we call the average. So this is the average velocities, and also we will focus on the here is the instantaneous of the speed. So like this. Okay, so this is the velocities, and here is the speed, here is the velocities. Okay, so when we finish all this, how to describe how fast, maybe we have another way to help us to know if we want to just use the diagram to help us to illustrate, or maybe here help us to figure out. So we can use the diagram to help us to know the change in the change of the motion state. So like this one. So the first step when we want to introduce is the displacement pursues the time. So this one, delta x, this delta t. So if you get a diagram like this one, so that means that the object is just at rest, right? So if the here is if there is a slope, there is some line with a slope, and which means that this motion actually with the uniform velocity. Okay, so also that if your curve your line is actually is a curved line, and this is a parabola lines, or maybe the parabola curve, things that. Okay, and also that if you want to change this one into the another kind, we call the velocity versus the time. That is one. So this is the v, and here is the t. So you can get the first that this is at rest or maybe the zeros, and universal and universal velocity is just like this one. And also that the parabolic is just like this one. Sorry. So this curve is a parabolic. This curve is the acceleration, uniform acceleration. Okay, so this is the some diagram to help us to know the state of the motions. So when we finish off of this one, so here I want to I will want to introduce another definition, that is the acceleration a, like this one. So this is the average. And also you can get the instantaneous acceleration. That is one. So this is the instantaneous. Okay, so if you want to know the motion of states, you just use the diagram above, or maybe you can use these physical quantities can help of you to know the exact ways of the physics state. Okay, so now this section will stop it, and we were talking about the more advanced content about the kinetic in the elective physics. So this next section I want to start to talking about the motion by the Newtonian mechanics. So see you next time. Bye. This is Peter.